Okay, let's do piecewise function. A piecewise function is a function defined differently on different pieces of its domain. So if we look at this, when x is less than or equal to 0, we're going to follow f of x equals x. And if you look at the graph, we can see that when x is less than 0, the graph is f of x equals x, that linear line. If x is between 0 and 1, then we're going to follow the equation 2 minus x. And if you look between 0 and 1, we've got that graph 2 minus x, y-intercept of 2, slope negative 1, negative x. And when x is greater than 1, we're going to follow the equation x squared. So if we look at greater than 1, it's kind of hard to tell in this, but it does slightly curve up, showing that quadratic of x squared. So, let's see. Let's try and graph one by ourselves. This piecewise function has two pieces. I'm going to graph the first one and then have you try and do the second one on your own. So this first one, I only want to go when x is less than 1. So I'm going to kind of box the area that I'm working with. I want when x is less than 1. Now I'm going to graph the absolute value function. Absolute value of x looks like this. Pardon the bell. Right there. And like this. Right there. But I only want to graph this in my box. So I'm actually going to erase this one and only draw it up to there. Now, there's one thing we didn't talk about on the other picture. You see all these different kinds of circles right here? That's very important, and especially when we talk about limits, which we're going to start next chapter. Basically, your open circle means up to, but don't include. This should sound familiar. AKA, it's your parentheses. AKA, that's your greater than, less than. Closed circle means include. AKA, your brackets. AKA, less than or equal to, greater than or equal to. So if you look at this one right here, it says x is less than or equal to 0. So that means for that part of the piecewise function, we're going to have a closed circle, which you can see right there. These ones are both less than, so that's going to be our open circle, which you can see on the left side of that piece. On the right side, it is an open circle, but it's overpowered by this x then greater than or equal to 1, which is our closed circle. So that closed circle is on top of that open circle. That's why you can't see the open circle on both ends. So let's go back to this one now. I want x is less than 1. Is that going to be an open circle or a closed circle? Going to be open. So at the end of this, I'm going to put an open circle. Now I want you to do that second half, x plus 2 for x is greater than or equal to 1. Make sure you're graphing it on the right section, only when greater than or equal to 1, and make sure you watch your circles. Okay, hopefully this is what you got right there. And we have a closed circle because it's greater than or equal to. Now let's talk domain and range. Our domain, what x values does this graph hit? Now we have arrows, so it's going to go to negative infinity and positive infinity. The next question is right there. Does that line hit the graph once at 1? And the answer is yes. Because we have a closed circle there, your vertical line test is hitting the graph once. So our domain is going to be negative infinity to positive infinity. Now for our range, what y values does this hit? Well, looks like when we combine them all together, our graph is going to hit all the y values in the top half of the graph. So that would be from 0 to infinity. Now, do we include 0 or not? Yes, we do. So we want a bracket right there. Okay, that is all for piecewise functions. In the next video, we'll talk about zeros.